Okay, let's get started. Parabolas, ellipses, and hyperbolas. First up, parabolas. For the first 7 problems, we are to sketch the graph of the following parabolas. The graph should contain the vertex, the y-intercept, x-intercepts, if any, and at least one point on either side of the vertex. Okay, let's get started. So, usefully, this is in vertex form. It's in vertex form, and so we should be able to just read off what the vertex is from it being in this format. All right, so vertex form, what's that? That's where y equals a, x plus h squared plus k, like that. And isn't the vertex h comma k, if I'm not mistaken? But, you know, if you're in an exam situation and you forget, you can always verify by thinking about what else you know. So I know that the line of symmetry is minus b over 2a. And I know that if I were to expand this out, I would get x squared at 8x plus 16, but then we have to take away 3, so plus 13. And so the line of symmetry would be negative 8 over 2, which is negative 4. And then, so that establishes the x-coordinate. The x-coordinate would be negative 4. And for the y-coordinate, let's see. Well, if we plug in negative 4, we get 16 minus 32, which is minus 16, and then plus 13, which is minus 3. Okay, so it appears that vertex form is more accurately put as x minus h x minus h squared plus k, like that. All right, so that's the vertex, if I'm not mistaken. As for the y-intercept, that we can just see on the end is 13. How would we obtain the y-intercept when it's in vertex form? Just square out this number on the end here and then subtract 3. As for the x-intercept, well, I guess we have to complete the square. We can just complete the square here. Then that would cause a minus 16, so a plus 16, so 3. Oh, I remember. Okay, so it's h plus or minus root k, it appears. Or so I think. Until I realize that there is a right there looking at me. Anyway, we've established what the x-intercepts are in this case, -4 plus or minus root 3. And that's enough to graph it, is it not? Just thinking about what would be best. Okay, so the y-intercept is 13. And the vertex is -4, 3. No, -4, -3, beg your pardon. And the x-intercepts are -4 plus or minus root 3, which is -4 plus or minus 1.732 approximately. So I think this portion would be quite fine for the job. All right. Oh, darn it. Well, I suppose that's... no, that's not. Okay. I got off the vertex point. Okay, so let's get them now. -4, -3. There you go. There's the vertex. 13 is the y-intercept. And the x-intercepts are -4 plus or minus 1.732. So it looks to be something like there-ish and something like there-ish. And this is very rough, this sketch. Oi, man, that's horrendous. Well, you try your best. Let's have a look. Yes, that was it. X A open brackets x minus 8 all squared plus k. Sometimes I might drop a sign from memory. Okay, so they obtain the vertex quite easily. All right, so they obtain the x-intercepts. Okay, so when it's in this format, yes, it's easier to solve. Just move that. All right, okay. Okay, yes. Best as I could, sort of there. I guess that makes sense that you would mark all the new points that you found. Why is that page open? Well, let's try for problem 2. See if we can do better than that. Okay, so it being in vertex form. Now, the y-intercept, I think I can just sort of get that straight away. I square this out, I get 1, times that by 5 to get 5, take away 20 to get -15. So I think that comes very quickly. The x-intercepts, now I think I can get them quickly as well, because I visualize it being set equal to 0, move the 20 over, divided by 5 to get 4, square root that to get plus or minus 2, and then move the 1 over. So 1 plus or minus 2, 1 plus or minus 2, so that would be -1 or 3. But the vertex, that's a question. Right, so it's not just simply 1, 1 comma -20. It's not, it can't just simply be that. So let's find out. Let's find out. All right. Okay, so expand. Line of symmetry, which in this case is 2AH over 2A. So those will cancel. We just get H. And then what? Well, I guess it would just simply be HK still. So I guess that's correct. So vertex form is actually pretty darn good. Oh, yes. And because the x-coordinate of the vertex should be the mean of the x-intercepts. Right. So it would be 1. It would be 1. Yeah, that makes sense now. Okay, and what's k? Well, -20. And does this make sense? Yes, I would say so. Okay, so we need the graph now. We need the graph now to sketch upon. So what should we look for? Okay, mostly from the 3rd and 4th quadrant. And let's go with this amount. Let's go with this amount. Three, two, one, there. Something like this. This should be good. Okay. The y-intercept was established to be -15. The x-intercept -1 and 3. And the vertex 1 and -20. All right, so that has to be graphed now. There's really no way to do this by hand. This is just sort of horrendous. But you try your best. Maybe if I sort of compress the coordinates on the y-axis, I would stand a better chance of graphing this. But otherwise, I mean, it just looks horrendous. It should be symmetrical. It should be symmetrical. And that doesn't look anything like it. So the only way in which I can make an improvement from last time is to acknowledge the actual points. So -1, 3, -15, and 1, -20. So we'll see if that passes. Okay, so they're fine. And look, he compressed the y-axis. So we have to learn how to do that on GeoGebra. I think I've done it once in the past before, but we'll learn how to do it again today. So here we have a parabola that's not in vertex form. So what do? Well, the y-intercept is very easy. It's just the number on the end, 7. The x-intercepts, it will have none. And we know this because the 3 in front compresses it horizontally, and the 7 on the end translates it upwards by 7 units. And that's a transformation of the unit parabola y = x², which is just on the origin point, that whose vertex is on the origin point. All right, so where's the new vertex now then? It should be the same as the y-intercept, 0,7. Now, as for sketching it, well, this one isn't so bad. I wouldn't say so. Let's give it a shot. Okay, so y-intercept is 7, as stated. Now, we have no other points, so we need to make some. In our minds, we can just pick up one and plug it in, and we get 10. It's symmetrical, so over here we'll get that 10 as well. All right, so trying hard now. to make it symmetrical. Sort of. That's reasonably okay. Let's check. Okay, that's good. All right, and henceforth, we, instead of like plotting them precisely with a piece of graph paper, we'll just sketch it by hand because it may look even better that way. And the point is to point out the key features. So here we go. Problem 4. X squared at 12x at 11. First, get it in vertex form. So x at 6 all squared. That creates a 36 out of thin air. So we need to subtract 36. And what's 11 minus 36? Negative 25. And there it is in vertex form. Okay, so now let's read off the vertex. I should be able to when it's like this. So I think it's negative 6 comma negative 25. The y-intercept, oh, you can abbreviate that as just y dash int. That's just 11. We can get it from the standard form, which is here. And then the x-intercepts, or the roots. Well, we visualize this as being set equal to 0. So move the 25 to the other side, take the square root, so that's plus or minus 5, and then subtract 6. So negative 6 plus or minus 5. Negative 6 plus or minus 5. And I'll do that there. Okay, so what's this going to look like? XY axes. Okay, so let's think. See, it's better when you're not trying to weave through points. It's somewhat passable now. But anyway, all right, so the y-intercept was 11. The x-intercepts were negative 1 and 11. And the vertex was negative 6 comma negative 25. And that should be okay. Yeah, that's fine. Next up, two x squared take 12x at 26. All right, let's get it into vertex form. We'll factor out 2. Now, when you square this out, you get 36. Double it, you get 72. But that came out of nowhere, so you have to take away 72. So what's 26 minus 72? That would be negative 46. Now the y-intercept should be 26. The x-intercepts, we don't know if it has any right now, but let's see. Visualizing it being set to 0, move the 46 over, divide by 2 to get 23, plus or minus root 23, so 6 plus or minus root 23, or so it seems. And the vertex, that should be 6 comma negative 46, if I did the calculation correct. And so let's try. Okay, so root 23 is something round about 5. So something like that, although not quite accurate, of course, but anyhow, 26. 6 minus root 23, and then 6 plus root 23. And then here, 6 comma negative 46. And we check. Whoa, that was way off. All right. No. Let's just try again. That was way off. Okay. Okay. Oh, I know what it is. I forgot to factor out 2 from there, from the 26. Anyway, yeah. Okay. That creates a... Oh, wait, is the heat still on? It is. Barely think with heat. All right, so x minus 3. That creates a 9, which I have to take away. So there's 4. That. Okay, that's better. That's better. Right, now, let's see. Okay, the y-intercept, that has to be 26, because look. As for the x-intercepts, Okay, set it equal to 0, bring the 8 to the other side, so -8 divided by 2, -4. Square root that and you get in trouble because those have no real roots, so it's actually floating above the x-axis, so none. And the vertex. Well, that would be 3,8. Okay, so let's just say 26. Something like that. That's fine and fair enough, I feel. Yeah, that's okay. For a sketch, it's fine. Okay, hopefully I don't make a mistake like that again. Now, I have to open the window. Even though that introduces noise, at least it lets in oxygen. Okay. So first factor out 4. There. Okay, that creates a quarter out of nowhere, so I have to take that away. And I take that away from the existing quarter, and I get nothing. So it's like that. Okay, so that's the vertex form. Now, what's the y-intercept? Well, that should just be 1. What are the x-intercepts, if any? Set it equal to 0. Square root, move that over. We get half. A half. And the vertex is a half, comma 0. Okay, so it has a sort of repeated root where it touches the x-axis exactly once. So, like that. 1.5. Yeah, that's fine. All right, so check it out. Yes, that's fine. And now for the 7th problem. Okay, so factor out that 3. Or perhaps -3. That creates a 1 out of nowhere. I've got to take that away, so take that from 2, so there. So like that. Y-intercept of 3. X-intercept. One plus or minus root 2. Vertex. 1,6. Now, how can that be? Well, because it's opening up downwards. Oh, no. That's not right. Okay. One minus root 2. 1 plus root 2. 3. 1,6. And check. Everything must be checked. And that's correct. And that's good. And now for problems 8 to 10. Let's have some water. Okay. Convert the following equations into vertex form. Okay, I will. F of x equals x minus 12 all squared. That creates a 144 out of nowhere. So I have to subtract it. 157 minus 144 is 13. So there you go. So factor out 6. And you will have x squared at 2x at 1/2. And then complete that square. Just like that. That creates a 1 out of nowhere. So you have to subtract it. 1/2 minus 1 is -1/2. And then expand it out. 6 times -1/2 is -3. And last, Okay, so let's factor out the negative sign. And we will have x squared at 8x at 18. And then within the bracket, let's do that. And then we have 16, but we must subtract it. So then that becomes 2 when paired with the 18. And then finally redistribute and get rid of the outer brackets. So it should look like that. And now we check. Everything must be checked. Okay. Okay, that's correct, and that's good. And that is correct. And that is correct as well. Okay, that's great. So put it in here. And begin something new. Ellipses. Okay, so what is an ellipse? An ellipse is like an oval, but it's a mathematically and technically precise oval. And it's of the form x minus h all squared over a squared plus y minus k all squared over b squared equals 1. That's the standard form. And it has two foci or foci. And that's about all I can summon into my mind about it right now. Oh yes, it's a conic section. So if you imagine cutting a cone straight, like that, at a bit of an angle, so it's not a perfect circle, you will create an ellipse. And it's the path that bodies take around when orbiting something much more massive than themselves, approximately. Anyway, so what does this ellipse here look like? Well, the center is negative 3,5, I think. And let's get the I don't know what you call them, left and rightmost points, maybe the horizontal extrema and the vertical extrema, something fancy like that. Anyway, yeah, so what would it be? h plus a comma k, h minus a comma k, something like that. Okay, so what? 3 plus 3 comma 5. I think. Okay. And this would be h comma k plus b, h comma k minus b. So -3. I have a feeling this is completely wrong. Yes, it is. Because look, that's 6. How can that possibly be the case? How can the center be -3 comma 5? Right, okay, so this is wrong, and so this must be corrected. Okay, so I'm misremembering it, aren't I? So that should be... So h in this case is actually -3. It's not 3, it's -3. So, I mean, isn't it kind of obvious that it would be -6 and 0? I mean, what is the center for? It's symmetry, right? Okay, that's a good point. Yeah, I think I get that. Yeah, that sounds correct. That sounds fine. Now, let's think this through logically. What would that be? 5 plus √3, 5 minus √3. How about that? You know what? This is wrong as well because it's not in the right order. So that should be 0 there in the first slot, and then -6 there in the next one. So I think that's okay. But I must sketch. I must sketch it. But how to do this? Okay, so it's like over here. No, it's not. There. And there. And there. And there. Okay, let's see if this is possible. Oh, yes! I did it! Brilliant. Okay, I'm super happy about that. All right. But that was way too slow. Need to get much better at this. Okay, let's think. Turn it into standard form straight away. So I'm going to say you know what? I'm going to have a 0. a negative sign in there. There. Right. Center h comma k, so 0 comma 1. Right and left, yes. Now think. The right and leftmost points must have the same y coordinate as the center, mustn't they? But varying x coordinates. So there. The top and bottom must have the same x coordinates as the center, but varying y coordinates. So think it through. Plus or minus 2. Oh no, that's in the wrong order. Hello. I mean, it doesn't matter logically, but you know. And that's in the wrong order as well. Right, anyway. Sketch this. What? Oh, right. The center is up there. Okay, this is actually taller than it is wide. So this isn't quite right how it looks, but did I figure it out? Yes, that's all okay. That's good. Okay. Next one. Well, it has a multiplying factor of 4 in front. So what does that mean? That's the same thing as dividing by a quarter. So if I were to put it in fully standard form, a quarter would be on the denominator, but then in real standard form, it would be a half squared. Wouldn't it? Yes, it would. Like that. And here, like that, like that. Okay. That's good. Now let's get the center. So I say it's going to be -2, -4. And let's get the right, left. Think it through logically. We'll have the same y coordinates as the center. But what? It's going to be the -2, but plus or minus a half. So -2.5, -1.5. So think, visualize, it will be a very skinny ellipse. And once again, I do not have them in the right order, but I'm kind of sick of correcting that, to be honest. No, correct it. Okay, -1.5, -2.5, there. Okay, let's think. Top and bottom will have the same x coordinates as the center. So -2, comma, and then -2, comma, there. But what's the variance? -4, -2, or -4, +2? There. Now to sketch. Now to sketch. There-ish. Oh no, that's not right. -2, there-ish is better. And there, and there, and very skinny now. Yes. Better. I got you. That is correct. Okay, now, fourth problem looks interesting. For problems 4 and 5, complete the square on the x and y portions of the equation and write the equation into the standard form of the. All right. So let's do. Okay, what to do now? Bring out that 3. No, that would be y minus 2. Too much. A little bit too much is going on all at once, so I have to break it a little bit. Okay, now for this portion here, how to take care of that. That will create a 1 out of nowhere, times that by 3, so it creates a 3 out of nowhere, and that has to be subtracted to keep it valid. So there's the rest of it. Now, bring it all over. -16, that turns into -19. -19 plus 12 is -12. -19 plus 7 is -12. Bring that over, it turns into 12. Okay, so this is looking more like what we want. But what to do now? Divide everything through by 12. Okay. And that's the standard form. But I guess if you really, really wanted it in the standard form, what's that? Square root of 12. That would be 2 root 3. There. Let's check if that was done correctly. Okay, that's good. The last step, I guess that wasn't needed, but otherwise we agree. Okay, next one. Okay, first bring out the 9. So we had x squared plus 14x plus 4y squared minus 8y equals minus 469. When I do this, I make 49. 49 times 9 is 441. So I have to take that away. When I do this, I make a 16 times 4, so I make a 64, but I've got to take that away. And now I need to fix this fully. So that's what? Negative 505, and then add 505. So that would be 36, wouldn't it? Now divide it through by 36. And that should be okay. Yeah, that's all good. And save it. Okay, so the next thing to do is to look at hyperbolas. Okay, so what's a hyperbola? The standard form of an ellipse, which is an oval, is x minus h all squared over a squared plus y minus k all squared over b squared equals 1. The standard form of a hyperbola is x minus h all squared over a squared minus y minus k all squared over b squared equals 1. Very, very similar. They just differ by that middle sign. So an ellipse looks like this. In standard form. And a hyperbola looks like this. But these pieces here can swap around, and that will determine if the hyperbola looks like this or if it looks like this. This one right here will kind of look like this. Wait, let me try. It's going to vaguely look a little bit like this. Like that, right? And there'll be some like asymptote there and an asymptote there, which it gets closer and closer and closer to, but never touches. All right. So anyway, enough of the blah, blah, blah. Time to think about what the hyperbola actually even looks like in the first place. So how am I going to do this? Okay, so the point of this is to be in vertex form, is it not? I have no idea. I'm completely drawing a blank. Completely forgotten how this works. So rather than run the risk of getting it entirely wrong, I just want to sort of remind myself. Okay, the center is h comma k. That makes sense. And it opens left and right in that format. That makes sense. And the vertices are h at a, comma k, and h take k, comma k. That makes sense. Plus or minus b of a. Slope of the asymptotes plus or minus b over a. Slope of the asymptotes plus or minus b over a. Must remember. Right. Let's try now. Like, let's think about what are the actual ingredients that I would need to actually get this job done. I need to know if it opens up left and right or up and down. That is absolutely fundamental. Okay, so this one here is going to open up and down. This will open left and right, and this will open left and right. Okay. I need to know where the center of the hyperbola is. And then for the vertex, I think I can just sort of think it through like I did with the ellipse. Guess so. Anyway, I'm going to try my best here. Center, in this case, wait. I'll do it like this. Opens, up, down. Center, 0, 2. No! That doesn't make any sense. Surely it would be 2, 0. 2, 0. Right? Okay. Vertices. Let's do it. Look, we just have to think that it will be the center, but a slight modification of the center. Which coordinate makes sense to modify for a hyperbola that's opening up and down? Oh, the y coordinate, right? That's it. But by how much? By 3. I mean, that's why it's in this standard form, right? Exactly. So 2, minus 3, 2, 3. That's what I think, but I don't know that for sure right now. Okay. No, totally wrong. Because we're not thinking, because we're looking at the wrong thing. Okay, fine. 2, 4, 2, minus 4. How about that? Okay. Okay, we'll just try. And we'll see what it is that they say about it. Okay, so 2 to the right and 0, and then 2 to the right. There. There. Okay, so there's my first attempt. Yeah, just first attempt at sketching the hyperbola. Let's see how it goes. Okay, I like that, but notice they include the asymptotes. So I think that's a standard run-of-the-mill thing that they expect of you. And what that means is you got to learn how to do it. You'd have to learn it anyway, but you better learn it now. Slope of the asymptotes, plus or minus b over a, plus or minus b over a, plus or minus b over a, plus or minus b over a. We get it, we get it, we get it. Equations of the asymptotes. Now. K plus or minus b over a, x minus h. K plus or minus b over a, x minus h. Okay. Problem 2. We try again. Okay. First, this hyperbola opens right and left. Next, we get the center of the hyperbola. And what is it? -3, 1. Then we get the vertices. The vertices of the hyperbola. So it'll be a modification of the coordinates of the center. And what modification will it be? It'll be a modification to the x coordinate. That's what logically makes sense. And it's -3, -2. And -3 plus 2. There. Now, the asymptotes. Let's see if you can get it. So it's going to be k plus or minus b over a, x minus h. So 1 plus or minus b over a, so 3/2 x minus h. Literally, you just copy and paste what's there. And that should be good. That should be good. Let's see. -3, 1. There's the center. Okay, so let's get ahead of him. So 3/2x plus 5.5 plus 5.5, I believe. And minus 3/2x minus 3.5. And let's check it out. Let's see if we did better. than before, because it's all about doing better than what you did before. That's correct. That's correct. That's correct. And that's correct. Okay. I love it. We did it better. Third one. First, it has to be in standard form. Multiplying by 3 is the same as dividing by a third. And dividing by a third is the same as dividing by the square of the square of the square root of a third, which is 1 over root 3, which is root 3 over 3. All right. There. Okay, so there's our formal procedure. Just converting it into standard form. Now, first, most important thing we can tell someone is how does the parabola look from afar? And we shall say to them that it opens up right and left. And that's a little courtesy sketch right there. You know? And now what about the center? What about the center? Okay, so that should quite simply be 1, negative 1. Now, what about the vertices? It'll be a modification of the center because it's opening up right and left. Just the x-coordinate will be modified. But in what way? It'll be 1 plus or minus this thing right here. Root 3 is 1.732. Divide that by 3. You get something like 0.6. Okay, so 1 minus root 3 over 2, negative 1, and 1 plus root 3 over 2, negative 1. Those are my vertices. Now, as for my asymptotes, logically, it should be y in the form y equals mx plus c. Okay, but what does that actually look like? Well, we pull off the k there, so it should be negative 1. And then plus or minus, it has to be b over a, like changing y over changing x. That's how it roughly makes sense. So 2 divided by that thing right there, which is the same as 2 multiplied by its reciprocal, so 6 over root 3. So 6 over root 3 is 6 root 3 over 3, so 2 root 3. And then x minus 1, just like that. Okay, first, where is the center? 1, negative 1, so something like there. Then, wait, well, we can put it out further than that. We'll just say it's like there-ish. Yeah, all right. Now, where are the vertices? So, 1 minus root 3 over 2, that'll be real close. And then 1 plus root 3 over 2, something like there-ish, right? Yeah. Doesn't look very symmetrical, but I'm trying my best here. Okay, I'm not fully sure plugging those points is the best idea because it'll clog the room. Yeah, that's fine. We can leave it like that and just check. Mm-hmm. Okay. Darn it. That's actually not correct. All right, so we must figure out why. Why did I divide that by 2? Huh? I guess I copied that down wrong. Darn it. And that fixes it. And for the asymptotes, oh, darn it. That's the square root. Oh, darn. Okay. You caught me. You caught me. I didn't see that. Root 2. Root 2. It should be root 6. Okay, that's fixed now. Next. Complete the square to get it into the standard form of the hyperbola. All right. Okay, okay. Like that. Okay. Right. Minus 625. Plus 625. Plus 625. So 16, and then minus 16. Mm-hmm. Will that be over 16? And then that 16 over 400, will that be 1? Okay, now we'll check these out and see if these are correct. Good. How did I drop the +1? Where is it? Where is it? Oh my goodness me. Look, there's a +1, there's a +1, there's a plus and a plus and a plus, plus, plus. That's it. All right. But other than that, that's studied now. Next time I come to Paul's notes, I'll be looking at miscellaneous functions and transformations and symmetry, hopefully. Be well, be well.